Use McMaster Carr parts in a design. In this video, we'll insert a McMaster Carr component. In Fusion 360, we want to carry on with our gear reduction housing assembly. At this point, we're going to talk about inserting hardware into the design. So the first step in this process is to use inspect and measure the geometry. First, we want to inspect the diameter, and in this case, you'll see that it's 6 millimeters. And then we want to inspect the overall length. So you'll note that this is 16 millimeters as the minimum distance. Depending on the design, you might have a threaded portion of the housing, or you might have to have a bolt go all the way through with a nut on the backside. For this specific design, we're going to talk about using a threaded portion in the housing, so we want to make sure that our hardware is less than 16 millimeters so it doesn't stick through. It's also important to note that this hole here is a bit longer, and you can see that it's 24 millimeters. So if we're going to be using a bolt to hold the front housing all the way to the back housing, we need to make sure that we account for that. We can do this by going all the way from the front housing all the way to the back, a distance of 27 millimeters. So we're looking at about a 15 millimeter bolt and a 25 millimeter bolt. Next thing we want to do is we want to insert hardware from McMaster Carr. Now, it's not required that you use McMaster Carr, but there's already an add-in inside of Insert that allows us to navigate the McMaster Carr website and insert it as a 3D model. So this can be extremely handy, especially if you use McMaster for your hardware. The first thing that I want to do is I want to resize this so it's a bit easier to see. Then I want to begin navigating by going to Screws and Bolts, setting my system of measurement to metric, and then determining my thread size. In this case, we're going to be using an M6. Next, we want to talk about the length of hardware and the head type. The first bolt that we're going to use is a 15 millimeter long bolt. Then I can determine the type of head that is required for this design. In most cases, we would likely go straight to a socket head, but in this case, I'm going to select a rounded head. From here, we have two choices, a stainless steel and a metric alloy steel button head. When we look at these two choices, it's important to understand the differences between our material choices and whether or not they work in our structural applications. For example, the difference between a stainless steel bolt and this alloy steel is about 100,000 psi in tensile strength. So going from 70 to 170 is quite a big difference. So if your design is requiring a structural piece of hardware, then you need to make sure that you take these things into account. Also note that the alloy steel button head is actually a black oxide, which is essentially a sacrificial coating. This alloy steel screw is only mildly corrosion resistant. This means that if there's any humidity or moisture in the environment, this is likely going to rust relatively quickly. Notice that it does have blue dyed zinc plating as an option, but again, we need to be careful with our material choices. For our example, it's not going to matter, so I'm going to use the metric alloy steel button head because the geometry is going to be exactly the same. Once I select the part number, the next thing I need to do is select the file type as a 3D step, but note that they have a 3D step with no threads. Depending on your specific needs and also how much hardware you need, you can pick the one with no threads because it'll be less intensive on the CPU. For our example, however, I will be using the 3D step and then I'll select download. When we select download, it's placed as a component inside of our browser, and then we can manipulate it using move copy. I'm going to begin by rotating it 90 degrees, and then I simply want to move it out away from the housing, and I'll select capture position and OK. While this isn't the final location, I do want to make sure that it is visible on the screen, and then I can go back and use Insert, McMaster Carr, and find another bolt that matches. So we're going to expand the window again. We're going to take a look at those rounded head screws, metric, make sure that it's M6, and this time we're going to be using a 25 millimeter long screw. Notice that we have a few more options here. Because we want to make sure that we use the same type, I'm going to select black oxide and note that we have three different ones. We have a metric alloy steel button head, then we also have a stainless steel that has black oxide coating, and then we have one with a Phillips head. We're going to take a look at the metric alloy steel that's similar to the one that we already selected, and we're going to download that as well. You'll also note when you're selecting hardware from McMaster Carr that the part numbers are going to be representative of the geometry. So in this case, 91239A, and we have an 813 and a 327. So the first portion of the part number is the same, and the second portion is different based on the size. So we're going to capture its position, and now that I have these two pieces of hardware in place, I can use things like move copy or align to put them in the correct position. It's also important to note that we can use joints to align them to the correct position, but we haven't learned about joints yet, so we're going to focus on a tool that we already know, and that's modify and align. We're going to make sure that it's set to components, and we're going to begin with the larger hardware. I'm going to hover over the bottom face, hold down Control or Command, and then go to the center position of the bolt. I'm going to rotate around, hover over the face of my front cover, hold down Control or Command, and then move to that position, and we'll select Capture. Using my right-click marking menu, we're going to repeat the align on the other piece of hardware. So we want to rotate it around. Again, hold down Control or Command to find the center of that bolt. If you chose to use one of the step files without threads on it, the selection process is a little bit easier. Then we want to select its position. We're going to capture its position, and we're going to say OK. Because we know that we use symmetry when designing this housing, this means that we can use things like mirrors or patterns in order to fill the rest of the positions. This could be done with a circular pattern for the outside of the housing, or we can use a mirror. In order to do that, however, I need to place one of the bolts in this other location, and then I can mirror it top to bottom. In order to do that, I'm going to take the long bolt, I'm going to right-click, and I want to copy it. Then I'll right-click, and I'll paste it. When I paste it, you'll notice that it's a second instance of the same bolt. I'm going to manually move it off to the side, and then I'm going to use my Modify and Align, and once again, select the bottom of the bolt, holding down Control or Command to select that center point, and then we'll do the same thing on the housing. We'll capture its position, and then we'll say OK. Now that we have the hardware in place, I'm going to go to Create, and I'm going to select Mirror. I'm going to start by selecting Components. The component that I want is the shorter hardware, and the mirror plane is going to be the default YZ plane in this case. We'll say OK, and note that now we have a mirrored version of it here. Once again, when we take a look at the components, when we have a mirrored version, you'll note that it actually creates a new component. When we have a copy, it's the same component but a second instance. This is problematic when we get downstream and we begin talking about creating things like bill of materials and parts lists, because the mirrored version of the component is an opposite-handed version. If we right-click on the mirror feature and edit, we don't have an option to actually create an identical component. So if you are worried about the bill of materials downstream, then using something like mirror is not a good option. So we're going to select mirror in the timeline and select delete. Then from the create menu, if we go to pattern and select circular pattern, we'll set it to components. We'll select a short hardware. And then for the axis, we just need to select the center of revolution, the number of instances, and then we can say OK. Now, if we look at the name of the hardware, you can see that it has a colon and a 4 after it for the fourth instance, the third instance, the second instance, and then back to the original is the first. This means that on a bill of materials, they'll show up as quantity 4. We need to do the same thing for the longer hardware, but unfortunately, we don't have a pattern that'll work for those. So really that comes down to creating copies and moving them into position with Align. So that's a great opportunity to play around with Align and using copy and paste. So go ahead and save this design. Then use copy and paste and align to take both of these pieces of hardware and create a new copy of them inside of the other two positions. From there, go ahead and move on to the next step.